Simplifying radicals. Okay, we just learned how to simplify square roots. This is going to be on how we need to simplify cube roots. Okay, so once again, some helpful vocabulary. Radicals is any expression containing a root, and here is our parts of a radical. The only difference is now we have this 3 right here instead of a 2 or nothing. If there's nothing there, it's considered a square root. So what we're going to do is we're going to break this down just like we did with square roots. We're going to do the prime factorization, but in the end, instead of finding groups of 2 like we did with square roots, we're now going to find groups of 3 because it's a cube root. Okay, so let's break this down and you'll see what I mean. So 500 is the same as 50 times 10. 50 is the same as 10 times 5. 10 is 5 times 2. And this 10 is also 5 times 2. Okay, so my prime factorization, we have 5 times 5 times 5. So I'm going to use this 5. 5 times this 5. Times 5, I use that 5. Times 2. Times 2. Alright, so now I'm looking for groups of 3 because it is a cube root. So if we notice, here is a group of 3. Alright, so what happens is if we take this group of 3, two of the group of 3s don't make it out, and the 5 comes out, and left over is these two 2's. 2 times 2 is 4. So my answer is 5 times the cube root of 4. So you find a group of 3 because we need 3 to get out of the root. But as we're getting out, 2 of them disappear, and there's only 1 that actually gets out, but the group of 3 to help it get out. So if we look at this one, we got 108. All right, so if we break this down, we get a 9 and a 12. And notice it's a negative. That will come into play also in just a minute. So just keep that negative in mind. So 9 breaks down to 3 and 3. And 12 breaks down to 4 and 3. And 4 is the same as 2 and 2. So my prime factorization, I get 3 times 3 times 3 times 2 times 2. We use those 3 3's and those 2's. Alright, so we have a group of 3 right here. Remember, 2 of them don't make it out of the radical, but the third one does. And what's left inside? I got 2 2's left inside. They couldn't escape because there wasn't 3 of them. So 2 times 2 is 4. Okay, back to this negative. Since it is a cube root, we can actually, what we can do is just bring out the negative. Because negative 1 cubed is just negative 1. So the cube root of negative 1 is also just going to be negative 1. So when it's a cube root and we have a negative inside, it's as simple as just bringing the negative out. There's no worry about anything. If it was a square root, it'd be a whole different thing, which is actually what our next lesson is going to be about. But for this particular one, since it's a cube root, we can just bring out the negative, and there would be my answer. Okay, let's try this one. So we got negative 108 times x cubed times y to the 8th. So we just broke down the 108, so let's break it down again real quick. So it gets us to 3, 3, 4, 3, 2, 2. Okay, so if we do the prime factorization, we get 3 times 3 times 3 times 2 times 2 again. And now we have 3 x's, x times x times x, and we have 8 y's. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to look for groups of 3 because we're looking for a cube root. So here's a group of 3. That 3 comes out. Here's a group of 3. And x comes out. Here's a y, y, y. The y comes out. Here's another y, y, y. We need 3 of them to get out. Those 2 cross off, and I'm left with that one. And then those 2 y's and those 2 2's are left inside. And instead of writing it as y times y, I can actually rewrite that as just y squared. And what was left inside? 2 times 2 is 4. and y times y is y squared. So we're just looking for groups of 3 now to come out. Oh yeah, and we can't forget about the negative. I had a negative, and since it's a cube root, the cube root of -1 is just -1, so the negative can come out right there. Alright, so there's that one. Hopefully that makes sense. If you have any questions, please email me. I'll be happy to answer any questions you have.